Welcome everyone to the OpenShift 4 demo today by Shadowsoft. My name is Jimmy Hendricks, James Hendricks formerly, but I go by Jimmy here around Shadowsoft. I'm a Red Hat solution architect around the Red Hat emerging technology stack, primarily OpenShift, Ansible, Satellite, all of those automation technologies that make life a little more livable. So we'll jump into that. Our goal today is to kind of discuss OpenShift as a platform and demonstrate some of the new features and layouts of the OpenShift 4 release. As of today, OpenShift 4.4 has gone general availability, which is great, and we're going to dive into a few of those new feature enhancements that have been built into the platform for operators and developers alike. But first, we talk about Kubernetes. And so what is Kubernetes? Well, Kubernetes is a portable, extensible, open source platform for managing containerized workloads and services. It both facilitates declarative configuration and automation of microservices. And really, what it boils down to is Kubernetes is a container orchestration engine. I think that we can all agree that Kubernetes has become the de facto standard and true winner of the container orchestration and management game. And it does a lot for you. When you're diving into microservices and containers, there's a lot of moving pieces that need to be taken care of and tracked. And Kubernetes does a great job of the orchestration of containers, as well as providing a few storage and networking plugins, pod scheduling and scaling, as well as some load balancing and unlimited security, as well as deployment and app discovery. That being said, though, Kubernetes done right is pretty hard. 75% of enterprise users identify the complexity of implementation and operations of Kubernetes as the top blocker of successful adoption within organizations. So, there's a series of uphill climbs that need to be made in order to get Kubernetes to be what we would equate to an enterprise platform. It's a great orchestration engine, but a complete platformized solution that's enterprise hardened and capable, it's not right out of the box. And so you can see here in the step process all these different things that you would have to do on your own with vanilla Kubernetes with your own organization in order to get it to a kind of platform-esque existence that operates in an enterprise environment. And even then, Kubernetes doesn't do everything. There's a lot of third-party plugins and tools that you would need to leverage in order to build a complete, container platform solution around Kubernetes. Features like multi-tenancy, advanced and deep-level metrics and logging, networking tools, and provided software-defined networking, image registries, image build automation, dynamic storage provisioning and resources, as well as CI/CD tools and pipelines. Some of these are the features that we'll go over today here with OpenShift, but these are just a few examples here on this screen that really show a lot of the lacking capabilities that Kubernetes provides out of the box. And really where Red Hat OpenShift steps in. Red Hat OpenShift, it's a secure enterprise-grade container application platform, and it's based around the Kubernetes engine. It's focused around traditional and cloud-native applications with a move or focus on cloud nativity in the future for organizations. So if Kubernetes is the engine, OpenShift is the total car. And there's a series of challenges that we're facing when we adopt microservices and containers, right? Things like container security, image scanning and patching, as well as various compliance standards we need to meet are all challenges organizations face when adopting container environments. Day two management for operations and administrative personnel, from installations of the actual tools like Kubernetes or OpenShift themselves, upgrades and maintenance, integration of existing enterprise technologies external to your container infrastructure. as well as application delivery, the monitoring, metering, and management of applications, as well as the integration of existing developer tools in a developer tool chain, are all challenges that exist here. Whereas Red Hat OpenShift is really focused on adding, livable features and environments to help combat these challenges that many organizations face when moving in this direction. Again, it's built on trusted enterprise Kubernetes. So providing that continuous security and support, as well as the surrounding services and expertise, allow you to confidently run any application within Kubernetes and on OpenShift. And OpenShift provides a cloud-like experience everywhere, from the full stack automated installs and operations built on a consistent and agnostic platform and infrastructure that can run on any hybrid cloud infrastructure or even bare metal on-prem. It also has a litany of tools that allows developers to continue to innovate and push the momentum to get applications to market and production faster, and supporting technologies that help streamline and automate workflows and allow developers to stay in a singular plane without having to move between different tools and environments. And really when it boils down to it, when we're looking at Kubernetes as being kind of the central engine solution, OpenShift really is the best choice built around it. From the over 1,000 customers that have adopted OpenShift, that deploy over 4,000 pods a day, to the code contributions that Red Hat makes to Kubernetes, being the lead developer and contributor to the Kubernetes project, to the strong cloud and infrastructure provider relationships Red Hat has built with all the major public cloud providers, the ISVs, and even systems integrators surrounding that, providing extensive container catalogs of certified partner images that are ready to deploy on OpenShift from day one. And then there's a comprehensive portfolio of various container products, services, tools for developers and administrators, even from storage and overall management, that are available to you, that exist right within the platform and are easy to install and set up through either our operator framework or developer catalog. And before we jump into the installation process differences in OpenShift 4, we need to discuss the differences coming from OpenShift 3 to 4. In the past, OpenShift 3, the platform wasn't tied to any underlying operating system or coupled to it. Obviously, RHEL was required, but a pre-existing RHEL installation was required on the host infrastructure to run OpenShift. Whereas in OpenShift 4, the operating system or underlying operating system is coupled with OpenShift in the form of Red Hat Enterprise Linux Core OS, or Core OS for short. And there's a number of key advantages behind this. One is the minimal Linux distribution creates a smaller footprint from a resource standpoint. It's been optimized for running containers and providing only what's necessary for OpenShift and the underlying containers to run. This means also decreased attack surface, so it's more secure. And with it being coupled with OpenShift, over-the-air automated updates and providing an immutable foundation for OpenShift clusters provides a level of simplicity and peace of mind, really, for administrators and operators for organizations. It's also ignition-based for those that are familiar with that type of deployment. And here we can jump into the two different installation procedures. The most common one that we've seen so far is the installer provision infrastructure, or otherwise known as IPI. And so on day one, we would do the OpenShift install, and day two, move on to general operators for the administrative environment. But what's interesting here is that this is a fully automated process from the installer and operator standpoint. No longer is there a super complex installation configuration file like there was in 3. This is all managed through I believe, Go. And now the process is simple as running a simple command, filling out your cloud credentials if you're installing on cloud, and everything is managed from the container platform cluster services and the cluster itself all the way down to the cloud resources and the underlying operating system there. So within 20 to 30 minutes in a single command with a few additional pieces of information, you could be up and running with a fully functioning OpenShift cluster and platform. Contrasting that as user provisioned infrastructure, still heavily automated and installer and operator managed. However, just a few elements are managed by the user themselves and provided information. So on the control plane masters, the cloud resources that would be associated with the deployed or the infrastructure you're deploying to would have to be provided by yourself and managed there in the installation procedure. And for any worker nodes for workloads or infra nodes, the underlying operating system and the cloud resources would also have to be provided by the user or delineated there to ensure that they're present. Overall, though, moving from OpenShift 3 to 4, OpenShift 4 provided a significantly more simplified, streamlined, and quicker installation procedure across both methodologies. And the operator framework that's provided with OpenShift delivers a number of great advantages. One is it being Kubernetes native. So anybody who has familiarity with Kubernetes, working within it, will be able to leverage the operator framework pretty quickly. And these operators help codify the human and operational knowledge and workflows that automate the lifecycle management from the applications to the overall administration and management resources within an OpenShift. And so what this does is provide a high degree of peace of mind, automation, and insight into how the cluster is administered and managed, as well as on the development side, we'll show a couple different operator framework additions there. And so administrators will find that the features in the 4.4 release continue to improve the access to operational functions that you really need every day. And those enhancements really start with new metrics dashboards. One of the advantages that OpenShift provides administrators and operations personnel is that there's deep level metrics and logging functionality. And on the metrics side, the monitoring visibility has also been extended to include the Red Hat operators. And so with OpenShift being a platform for multiple applications in the hybrid cloud, and as such, it being a part of such a native part of cloud technology nowadays and it being widely adopted with cloud providers, Red Hat now provides a cost management feature for OpenShift clusters, which combines both a view of a workload and cloud compute spend in one tool. And so OpenShift cost management gives the visibility to how each namespace or project is using resources and shows the cost associated with each project. And so what the advantages are here is that you don't have to rely on a proprietary or singular cloud provider cost management tool. You can have that in a single pane here within the OpenShift console and not have to be flipping back and forth, as well as understand what workloads are consuming what resources and at what rate. And on the developer side, there's a ton of self-service that's created there. Developers no longer are going through significant manual or human interaction, approval chains or access to resources. And this way, administrators are able to provide developers, and we'll show this soon here in the web console, a number of resources, templates, pathways, and approval chains that are automated into the actual console and platform itself. So developers can just focus on developing and innovating. And with that, Red Hat's really focused on delivering workflows that align with how developers work every day. And more every day, developers are moving towards serverless application architectures. So one thing that 4.4 brings to the table now in GA is the use of OpenShift serverless. So with this, developers can build event-driven applications and services to really run across a range of hybrid cloud infrastructures, really creating application agnosticity to the underlying infrastructure. With that, the serverless applications, they can really be triggered by a number of event sources and scaled up from and back down to 0 to handle load as required. So you can think of this as like an AWS Lambda or Azure Functions type of service and development style. And what's great about this, again, is just like with the cost management tool, you're no longer beholden to a specific proprietary cloud provider for this type of functionality. By decoupling it from a specific provider, you can take this type of capability anywhere where OpenShift is deployed. Another popular developer tool is Helm that's been included in 4.4, specifically Helm 3. And so what's great about that is the Helm community and the Red Hat have really addressed some of the underlying security concerns that exist with previous versions of Helm. And most prominently, the thing moving into Helm 3 that to keep in mind is that they've removed Tiller from it. So that boosts the security considerably. With including support for Helm 3 and making Helm charts visible and available in the OpenShift console via the developer catalog, this really just helps further improve how developers work every day, especially those who are coming from familiarity with Kubernetes and using Helm charts. Another thing we'll touch on later on, and I'll show a demonstration of, is OpenShift pipelines, which has now moved into tech preview. And this is based on the open source Tecton project. It's another serverless feature, and we'll get into that a little bit later. But it's a really cool CI/CD add-on included with OpenShift 4.4 that really allows developers to move and screen with continuous integration and continuous delivery and deployments. Beyond that, there's a number of other new features that exist here within 4.4. So one that's existed since the release of OpenShift 4.1 is the OpenShift Service Mesh. There's been some general enhancements around here, but some of the benefits of the OpenShift Service Mesh is greater developer productivity. So integrating communication policies without having to change application code or integrating language-specific libraries. It helps get ready for production, so it installs easily on Red Hat OpenShift, and it's open by default. So it's been developed in open source projects, and this is the downstream certified and enterprise grade ready version of that service mesh tools included from the Kubernetes community. And what's in this service mesh tool? First and foremost, Istio. So those that are familiar, Istio is an open source project that's used for integrating and managing traffic flow across services. And it works in concert with underlying cluster management tools like Kubernetes. Centralized components, sidecar proxies, and node agents will also work together to create the data and control planes over a distributed application. So for those that are deploying distributed applications, this is a really powerful tool that gives you tracing and visualization via Jaeger and Kiali as well, to understand what your network of microservices that make up distributed applications and the interactions that are happening between them are doing. So this can help with discovery, load balancing, failure recovery, metrics, and monitoring, as well as traffic management, observability, policy enforcement, service identity, and security. In addition to that, Istio is designed for extensibility to meet diverse deployment needs for developers, such as platform support and integration and customization. And really what this boils down to is these capabilities help greatly reduce the coupling between application code and the underlying platform and policy. This decreased coupling not only makes services easier to implement, but it also makes it simpler for operators to move application deployments between environments or to new policy schemes. And applications therefore become more inherently portable as a result, which is really the whole focus, right, of adopting a microservices architecture for applications. Another great tool in 4.4 that's been released is the image security vulnerabilities dashboard functionality. So this is great using the Claire security scanning tool in tandem with the Quay.io image repository. We can support both on-premise and external Quay registries and be able to scan those container vulnerabilities before they're deployed. It also is on the roadmap to expand to other vendors for integration, such as Twistlock, Aqua, Sysdig, and so on, to more easily natively integrate into the platform within our operator framework. And I believe as of today, Sysdig has an operator on the operator marketplace framework to deploy. OpenShift 4.4 also upgrades the ingress controller implementation to use HA proxy 2. With this, customers are going to get a higher performance ingress for Kubernetes hosted applications. This includes end-to-end HTTP2 support and more scalable multi-threading. This also delivers improved security and response for applications. And with improving that performance across the board, the reduction of time it takes to produce an ACL unique ID allocations, this has been reduced from minutes to seconds via HA proxy 2.0. It also provides the foundation for high-value ingress controller features in future releases and adds more Prometheus metrics monitoring insights to our HA proxy. So the takeaway here for operations personnel is we have greater metrics insights, and we're going to have greater control over prioritizing ingress traffic, as well as significant performance improvements in terms of speed. There's a new etcd operator. This just increases or speeds up cluster installation times. It's also good for disaster recovery and speeding that process up and making it more reliable. And then it's increased verbosity with events within etcd. OpenShift 4.4 also has a simplified installation procedure now for deploying clusters on Red Hat virtualization. So this easily provisions the best practices Red Hat recommends for OpenShift clusters. It's a CLI-based guided workflow, much like the IPI install. And it's supported in Rev 4.3.9, and hopefully here by the beginning of Q3 of this year, 4.4. Another enhancement to the OpenShift installer is the improved support for DNS forwarding. And really what this provides, especially on the operations administration front, is the OpenShift DNS will be able to resolve name queries for endpoints using DNS servers outside of the cluster, which really helps to more easily incorporate OpenShift as a container platform underlying hybrid infrastructure or distributed infrastructure. Back to that cost management tool. Again, we're able to track cost trends and visualize those costs across our infrastructure. We can also map the charges to specific projects or organizations or teams within OpenShift. And we can just show and have show back and charge back information also presented to ourselves. Again, really useful because we're decoupling it from specific cloud providers in terms of having to use their tools. And now we can do this through OpenShift, again, providing that single plane, single platform, single source integration to all the functions and operations you have to conduct day to day. And then that Helm 3 incorporation. So again, this just helps further improve how developers work every day, as well as the security associated with Helm by removing Tiller. And with that, Helm also ties in natively into the operator framework. So with this, we can package and install and move on to our automated day 2 operations via the operators that are existing within OpenShift. And you can see that there's a host of advantages that are provided here, namely around the seamless upgrades and easy install, as well as a full lifecycle management. And then the kind of autopilot automation that's provided by the operator framework. Now, touching on the OpenShift serverless, like I discussed earlier, and these will be some of our last few features we touch on before we jump to the console here, because I know everyone's kind of hungry and eager to get in there. Serverless is a model that allows you to build and run applications so that when an event trigger occurs, the application will automatically scale up based on incoming demand or scale to 0 after use and demand is reduced. Again, just like AWS Lambda, Azure Functions, but decoupled away from proprietary or provider-specific infrastructure. So developers don't need to worry about server provisioning or maintenance of the underlying infrastructure. What they can do now is they simply just write their code, package it in a container for deployment. And what this does is it helps organizations innovate faster because the application is abstracted away from the underlying infrastructure, and it can truly run anywhere. Again, increasing that portability of applications is what we're all about here, and increasing speed while reducing resource footprints and utilization. And this is based on the Knative project. And so really what's the benefits here is, again, we can run anywhere. So we can use Kubernetes and Red Hat OpenShift to build, scale, and manage serverless applications on any cloud, on-premise, or in a hybrid environment. We integrate with legacy applications to build modern serverless applications out of them and support legacy applications through event sources and manage both types of those applications on Red Hat OpenShift platform. We can also focus on business. With little to no infrastructure to set up and servers to set up, Knative allows developers to focus on building new products and further innovating their current products. Knative installs an OpenShift using the operator framework, simplifying that installation and automating the updates for management for day 2 operations. It's also operations friendly because Knative uses Kubernetes to help gain greater consistency and incremental scalability across applications and teams. And what you'll see here as we move on, and the same thing with the OpenShift pipelines, is that the underlying provider Knative here is going to become a standard just like Kubernetes for adopting serverless technology and application architecture design. What does that mean? For administrators, operations personnel, and developers, having standardized tools in the serverless component arena, just like Kubernetes has become a standardized orchestrated service, an engine, is going to mean that it's going to make it easier for people to build stuff together and pull stuff in to build even more complex distributed applications. Another cool thing here is the Tekton-based OpenShift pipelines, which is a serverless CI/CD pipeline engine. What this means is there's no engine or server that needs to be stood up here. Which is great because it's based on a Kubernetes standard framework. This is something things like Jenkins X are based around as well. And it's based out of the Continuous Delivery Foundation. And so OpenShift Pipeline is a Kubernetes-style CI/CD solution based around that Tekton open source project. But it builds on Tekton building blocks and provides a CI/CD experience through tight integration with OpenShift, as well as the Red Hat developer tools that exist for OpenShift. And it's designed to run each step of the CI/CD pipeline in its own container, in its own event, allowing each step to scale independently to meet the demands of that pipeline. So it provides a number of highlighted features here, which is the Kubernetes-style pipelines and standardization, using that standard Tekton CRDs or custom resource definitions to define pipelines that run containers in scale and demand. It runs serverless, so we're not having to stand up a CI/CD server, therefore reducing resource utilization, and actually means that our CI/CD process moves faster. We have full control over the team's delivery pipelines, plugins, and access control with no central CI/CD server to manage. It's an integrated CI/CD experience, and a streamlined user experience is provided through the OpenShift console, developer perspective, the CLIs, and the IDEs that are given out of the box. OpenShift also comes with a broad spectrum of static and dynamic storage endpoints and the OpenShift container storage add-on. These are the native plugins that exist for the dynamic storage endpoints. And these are made through persistent volume frameworks as well as persistent volume claims. And this is just how persistent volumes are consumed for stateful applications within OpenShift. OpenShift Container Storage is a stateful application storage service based around Ceph that provides highly available and resilient persistent storage for applications that require statefulness. This is static storage provisioning and how it looks in terms of a diagram. And then our dynamic provisioning, which is really what we're seeing more adoption of from our OpenShift container storage users. And what this allows is it just allows provisioning persistent volumes on demand when users request it, rather than administrators having to predefine them in advance and go through manual approval. We can set up these persistent volumes to have specific limits around them in the dynamic provisioning. And so when a developer makes a persistent volume claim or some other user, they get only that chunk available, that persistent volume available, and the best one that suits their application workloads. And so with that, we're going to move into our console. So here is the administrator plane of the OpenShift Container Platform web console. You can see we have our overview dashboard, which has our status in the middle, the details around our cluster, as well as the OpenShift version and the update channel. Our cluster inventory in terms of the number of nodes, number of pods, storage classes, and persistent volume claims and utilization. Resource utilization is underneath status here, which is great for a quick glance at where things are kind of at from an infrastructure resource standpoint, as well as activity from an ongoing activity and also recent event log. So from an administrative standpoint, we have our operators, again, based on the operator framework that help manage day two operations. You can see there's a number of tools here, from deploying databases for storage, various storage operators which help with natively integrating storage provided for workloads, networking operators that tie into a number of already existing providers that are popular, like Citrix, F5, and so on. Other things like cloud provider operators also make it very easy to ingest and integrate with existing cloud providers. We can see we've installed a few here. So we have our OpenShift pipelines operator, as well as our service mesh operators that have been installed. Other useful tools here is our workload management plane. So we can see the number of pods running within our specific project. You can see our Grafana for visualization and monitoring, which we'll touch here in a second, is available there, as well as our Istio service mesh, and then our voting application that we've deployed via OpenShift pipelines. We can see the various deployments we've created for application deployment, as well as the deployment configurations for specific applications. In this instance, our voting application for the front end. You can edit the YAML file for these deployment configurations straight from the web console here and save them in their versioned. We can create stateful sets, manage secrets within the web console, and also create config maps. Other interesting features is we can schedule cron jobs, other jobs, specify daemon sets and replica sets for various pods and stateless applications. Other interesting things we can do here as well from an administrative standpoint is manage our services. So within OpenShift, a service exists as a static endpoint within inside the cluster, so that no matter what pods exist as they come up and come down for a specific application or workload, that static endpoint provides the cluster the ability to have other applications in the cluster itself, the API, be able to interact with the static endpoint no matter where that application exists within the cluster. But for those applications that need to be externalized to the outside world so that customers or internal users in your company can access them, we create routes. And this is managed through the router container within OpenShift's architecture here. Here we can see that we have a number of workloads here that have external routes provided, which makes sense. Our monitoring dashboard, Grafana, our Istio, Jaeger, and Kiali service mesh dashboards that need to be available for various service mesh components and functions, as well as our Prometheus interface that needs to be externalized, and then our voting application. You can also leverage Kubernetes native ingress, and there will be more enhancements around this in later releases. And then going back to what I was saying for storage, in terms of stateful applications, persistent storage needs. We can create persistent volumes, and you can see that we have one that already exists here, which is an S3 based persistent volume, and making persistent volume claims. So if we wanted to claim a chunk of that persistent volume, or depending on the resource restrictions around it, all of it, we can make that claim here for specific workloads and tie it to an application. There's also storage classes that can be created. We can select a number of provisioners. As well as reclaim policies around those storage classes for dynamic provisioning. We can also take a look at our builds and build configs. We don't have any in here, but we do have an image stream for application that we deployed so that when that application is updated, and I haven't set up triggers today for our OpenShift pipelines. But when we get to that, if you were to set up triggers, anytime there's a new commit made, the serverless functionality would kick off an event, spin up that serverless pipeline real quick, in each individual step task container to update the application live and spin up new pods of the updated application or most recent version as it spins down the old version with a rolling update. And here we can see the build and deploy pipeline I created using OpenShift pipelines. This is a serverless pipeline, and you can see that we have our different steps here within our pipeline. Leveraging Tecton, we can see the different parameters we have to specify, the resources that it will leverage during those tasks, and the tasks themselves. We also have task references within here. And we can embed even further parameters using variables to specify tasks. We can also view our pipeline runs as they've been run throughout here. And the resources that are tied to this pipeline. Our tasks, and again, this pipeline runs. We're just gonna run this real quick, even though we've already deployed, just to kind of give you a taste of what that looks like and how easy it is. While that's running, we can step into monitoring. Actually, let me show you guys a log here. You can see how quickly it's going through the build process here. From the steps that we've given it within the build task. And in my experience from leveraging this over different examples, I find it to be considerably faster than Jenkins. And because it's standardized, instead of using a specific provider like Jenkins, and it'll become a standard across the community, it'll be significantly easier to work with. Instead of having to learn a specific tool, you can learn this and be able to use it in any Kubernetes-based environment. As an example, what we ended up deploying, going back to our networking and routes, was our voting app. We can just click this little external link here. And that takes us to our voting app. And you can vote here. Feel free to use that web address. If you have the time to type it in, you can vote as well, be able to see the results. I'll post that in the chat for those who want to vote on cat or dog. And something that's very important for operators as well is alerting and metrics. So with our alert manager, we can create alerts and see alerts that are firing within the system, that are pending, and the various severity levels that are available. We can also silence alerts. We can go into our Alert Manager UI. We can group alerts together. And we can see an alert from the OpenShift image registry that our image pruning has been disabled. We can also silence this if we want to. Beyond that, we also have our metrics availability here. So I'm going to just generate an example query. Let's say we want to draw that out to, I don't know, 2 days for some reason. We can see here that we can run various queries and add them. We can string them together, and everything is color-coded and laid out in easy-to-read format. Well, let's say that we want to go into the Prometheus UI for those that are more familiar or comfortable with that. We just would click that link there, the Prometheus UI. We can log in using our existing SSO credentials for OpenShift. And get into the Prometheus UI where we can run Prometheus queries or prom quels to get data. And then we have our dashboard here. For those who aren't totally in love with the Prometheus user interface, we can use this fun Grafana interface here, which I already pulled up. And here we can see the compute resources for the cluster and the Grafana displayed out in all these beautiful colors with all this rich information. All of this is also able to be customized to any level of granularity that you need from an operative standpoint. So as an administrator and operator, this gives you the insights and visual tools you need to be able to understand what's going on within your environment, within your cluster, within your workloads. All of this included with OpenShift out of the box. We can also manage our compute. So from a nodes standpoint or machines, which are just nodes that haven't been brought up yet, and we can set them as specific to our underlying infrastructure. So let's create machine sets and autoscalers for generating more machines to generate into nodes, and create specific types of nodes like an infrastructure node where we can run our routers or storage from that don't take up compute resources in your subscription. So you can see here that it's actually fairly easy to scale up, scale down, and scale out our clusters on our infrastructure where we need. We also have multi-cluster management, which we won't show here today. That's kind of its own session in of itself. If you have a multi-cluster setup on different various infrastructures, distributed infrastructure, we can do that. And then as far as other day two operations go, user management. We can import users using various methods such as LDAP, CSV, and so on, and then specify them into groups, the type of accounts and roles that they'll have, as well as bind those roles. We can see that I'm the only user right now here, but that there's a number of default roles that exist within the cluster that exist at different levels. So there are system-wide roles that are more related to services. There are cluster-wide roles that exist overall in the entire cluster, as well as namespace-specific roles. And a namespace is essentially the same thing as a project in OpenShift from tenancy standpoint. And those namespace roles are only tied to that specific namespace, meaning that they don't have application permissions outside of that specific namespace. It's also administration, so we can set up our cluster settings here. We can manage our namespaces. We can set resource quotas on various cluster resources, as well as limit ranges from a performance standpoint, as well as add our own custom resource definitions for creating our own operators. So if we need to integrate some sort of other tool, whether that's internal or external to the cluster, and set an operator for automation and watching around it, we can create a custom resource definition that gets tied to a custom resource that the operator would operate on. And for the last few minutes here, we'll jump into the developer console. So you can see that we've separated the administrator and developer into their own separate workspaces now. In this add area, we can go to our developer add, where we can add from Docker file, a database, generate a YAML file, Git repository, pre-existing container image, or using the developer catalog, where we can see that there's a number of existing certified developer images that are available here for things such as middleware or CI/CD, like Jenkins. JBoss, and other languages that we need to be able to program within. We can also spin up code-ready workspaces and for code-ready containers, which allows us to develop within our own IDE within OpenShift, so we never have to really leave the infrastructure and platform that we're on in order to develop, which is a great tool. That's its own separate session as well for developers. We can also look at application topology. So let's go back to our pipelines project here with our voting application. And wow, we can see our service mesh and all the applications that are tied together there. We can zoom out. We can see there are Vote API and UI. And then I want you to notice something here that's another marker. These little upper circles with the external URL link means that a route has been exposed for that specific application within our topology map here. So you can actually click on that, and it will take you to the external route. And then with 4.4, our developers also get insights into monitoring. So they have a monitoring dashboard that's provided out of the box. Metrics that we can run queries around using the Prometheus engine here, as well as look at events on our workloads that we deployed. We can manage our builds and build configs. We can manage our pipelines that we need to create, and administrators can create or can manage all the resources surrounding those pipelines. And then again, the inclusion of the Helm releases. We can look at our project details dashboard, see performance is there, as well as the number of deployments in the inventory and a number of components that also exist within the inventory, as well as the project access that's afforded to this project specifically. So you can see that this is streamlined and provided tools that are specific to developers, and none of the extra fluff or stuff to get in the way, distract or obfuscate or confuse developers. So by bifurcating and separating these two workspaces, we're able to allow administrators and operators to operate on their cluster, provide resources for the developers, and ensure that those resources are stable, managed, and even provide a heavy degree of automation around them to make life considerably more livable and easier for operators. Developers can focus on what they need to focus on most, which is innovating and ensuring that they're pushing the needle forward and getting their applications to market as fast as possible, while operators are able to provide a stable underlying infrastructure that developers don't need to worry about. And so with that, I hope you enjoyed our demonstration of OpenShift 4. If there's any specific feature or any specific category around OpenShift that you would like to see, please feel free to reach out to me. I'm more than happy to provide a virtual lunch and learn. If you saw something interesting or want to dive more into a specific topic set, namely things around CI/CD like Jenkins or Tecton serverless CI/CD, the developer tools like code-ready workspaces and containers, as well as day two operations and stateful apps management using OpenShift container storage and so on. Thank you again for attending. If you have any questions, please feel free to leave them in the Amazon Chime chat. We'll also have a survey that we've posted into the Chime chat here that needs to be here. Just give me a second to post that here. That I'd really appreciate if you guys could fill out. It gives us great feedback on how we can improve these sessions and provide more helpful information to you all. So If you could do that for me, that'd be great. And it also helps me tailor future sessions for specific features and functionality to demonstrate around.